Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Dragon Q6A from Radxa. This is one of the first single-board computers with a Qualcomm system on a chip, and in theory it's got more CPU power than any ARM SBC I've previously tested. So let's go and take a closer look. Right, here we have our Dragon Q6A, which is available with 4, 6, 8, 12 or 16 GB of RAM. And specifically, this is an 8 GB model for which I paid £61 from A-Race, where it's also priced at $79.50 or €69.95. And therefore, right now, the Dragon Q6A is actually cheaper than a Raspberry Pi 5 with the same amount of memory, although rising RAM prices may change this in the future. So let's bring in Stanley the knife and open it up. And here we are, we've released our brand new single board computer, which, as we would have guessed from the size of the box, has a Raspberry Pi form factor. Turning to the specifications, at the heart of the Dragon Q6A is a Qualcomm Compute System on a Chip, or QCS6490, with a Cryo 670 CPU. Cryo is the branding used by Qualcomm for its customized CPU designs that are based on an ARM Cortex architecture. Specifically, a Cryo 670 is octa-core with one 2.7 GHz Cryo 670 Prime core, which is based on an ARM Cortex A78, 3 2.4 GHz Cryo 670 Gold cores, which are also based on an A78, and 4 1.9 GHz Cryo 670 Silver cores, which are based on an ARM Cortex A55. As a comparison, the Rockchip RK3588 found in many SBCs has 4 2.4 GHz ARM Cortex A76 cores and 4 1.8 GHz ARM Cortex A55 cores. So, in theory, our Dragon Q6A should outperform an RK3588 SBC, and indeed we'll be testing this later in the video. In addition to its 8 CPU cores, the QCS6490 has an Adreno 643 GPU as well as a Hexagon MPU, which offers 12 TOPS of AI compute power. Next to the SoC we have our RAM, here 8 GB of 5500 low power DDR5. We then find a wireless module that offers Wi-Fi 6 and Bluetooth 5.4, as well as this 2230 M-keyed M.2 slot. This supports an NVMe SSD and, impressively I think on a lower cost ARM board, has got a 2-lane PCIe 3.0 interface. So we should get faster drive performance here on the Dragon Q6A compared to many ARM SBCs, including a Raspberry Pi 5. And again, this is something we'll be testing later in the video. Turning to the first lung edge, we have a Type-C USB-C connector for powering the board that requires a 12V input at 2 amps or above, although alternatively we can also supply 12V power via this 3-pin header. Next to lung, and quite rightly, we have a full-size HDMI connector that supports up to 4K output at 30 frames a second. Next to this, we then find the welcome but endangered species called a 3.5mm audio jack, and then finally, on the end, we have this, which is an EDL button for entering Qualcomm's emergency download mode. Spinning 90 on the first short edge, there are no surprises. We have got a gigabit Ethernet connector and 4 Type A USB ports, 3 of which are USB 2.0, whilst the 4th is USB 3.1 and also offers OTG functionality. Quarter turning again, on the second lung edge, we find a 40-pin GPIO connector and this 4-pin Power over Ethernet header. Lastly, on the second short edge, there's then a power switch and indicator LEDs, as well as these two wireless antenna connectors. But I shouldn't have said finally. No, that was a mistake, because under the board there's loads more excitement to reveal. For a start, under here we've got a microSD card slot. Okay, that's probably not very exciting, but we do have a 4-lane MIPI CSI connector for connecting a camera, as well as a 4-lane MIPI DSI connector for connecting an LCD panel. And if these weren't enough, we've also got these two MIPI CSI connectors for connecting more cameras. Yes, that is 3 MIPI CSI connectors for connecting cameras on this board. For good measure, we've also got a real-time clock battery connector. That's always rather exciting. And then in the middle of the board, we've got this socket that can take either an eMMC or a UFS module. And in case you're not aware, UFS stands for Universal Flash Storage and provides faster speeds than eMMC. UFS is still pretty new on single board computers, and I've covered it in depth in another Explaining Computers episode that I'll link in the video description. And so there we are, the Dragon Q6A, a new ARM single board computer that's very well specified at its price point. Right, I've now connected the board up, as you can see, including fitting this 256GB Raspberry Pi M.2 SSD, from which we're about to boot our operating system. With the right firmware, the Dragon Q6A happily boots from USB, microSD, NVMe SSD or UFS module in this boot order. But I wanted to show you maximum performance, and so here I thought we'd run the operating system from an NVMe SSD. For cooling, I've fitted the largest heatsink I've got that I could actually fit on the board amongst the components on the board, although it's still pretty small for a QCS6490 system. But I think it'll be okay for our initial demo, although I might try to rig some active cooling before running benchmarks in my next part of the video. I've also discovered that third-party coolers are now available, which I might try to obtain in the future. And I do find it strange that Radxa don't offer any official cooling solution. So, for now we will just muddle through with this heatsink, so let's turn on the power. Here we go, and I'll show you the boot in real time. It always worries me when we first boot, it's just black, isn't it? But something will happen soon, I'm sure. Something will appear on the screen to show us we really are booting. There we are. And what we're booting into is the latest edition of Radxa OS, which is based on Ubuntu 24.04 and has a KDE Plasma desktop, as we'll shortly see. Anyway, it's now time to select a user. There are 2 test users here. We will use the Radxa one at the top like that. The password is just Radxa. I must change it at some point, but for now it's okay. And well, now I'll go on to the KDE Plasma desktop. Here we are. And I'll let you know in advance, I'm very impressed with this new Qualcomm-based single-board computer. What we have here is a clean install of the operating system using the provided image of Radxa OS. I've done a few scaling changes I always do to make things read better on video so we can see things more clearly on the screen. And I have installed one application, which I'll come to in a second, but basically you're seeing what you get with the stock image. And it's pretty minimal. There are not masses of things available here. That's what pretty minimal means, Chris. It is. We've got the Firefox web browser. We've got video and audio players. We don't have LibreOffice here, although of course we can install it. There are settings, system applications, and utilities. And if we go back to system, the one thing I've installed is this, BTOP, which is a bit like HTOP, but it gives you more graphical stuff, as we can see. Some of my channel members said you should try using BTOP rather than HTOP, so that's what I've done, so we can have a look at all the stuff that way. And I'm particularly interested in this on this particular board because it shows us a temperature for the SoC up here, which is currently, what, 41, 42 degrees. Given I'm concerned about cooling, I thought I'd get something with temperature in it. HTOP, you can get it to display temperatures, but you have to install stuff to make it happen. It's here by default in BTOP. So there we are. BTOP showing us everything is perfectly happy. Amount of memory expected, all that kind of thing. We've got 8 processor cores, and temperatures at the moment are absolutely okay. If we launch the Firefox web browser, here it goes. You'll see again things are nice and responsive. This is certainly a system you could use for basic desktop computing. I'm sure some people will say to me, but this is an Edge AI board, Chris. It's not intended for basic desktop computing. Some people want to use it for that, and I can assure you it absolutely works. And I've come to this page on the website for the Dragon Q6A, so we can look at downloads. I think it is. There it is. And you can see this is where I got the operating system image from. It's slightly worrying because it says it is a test build for internal development, only used when specifically instructed by Radxa support. I've not been instructed, I've used it anyway. But all the images here have the same warning on them, so you've got to use one of them. Although you can also, if you want to, use some third-party images. We've got other distros available, and we will be trying out one of these later in the video. And you can try and guess which one I'm going to pick. Anyway, the other thing I've got here is the Christopher Barnett YouTube channel. Why? Because we have my test clip. Let's just bring that up and show you YouTube playback. All desktop systems should be able to play back video. And let's just go to 1080p initially, bring up stats for nerds, and it just works. The ducks are absolutely happy. 1080p playback, no problem at all on this system. And indeed, if I bring up here, we've also got 4K. Let's go to 2160p. Let the thing settle a bit. Come on, system, you can do it. Give us some more video back. There it is. And it's playing the 4K footage again without dropping frames. Obviously, it's doing it in a 1080p buffer at the moment because that's what we're recording at. But this is fine. I am very impressed with the desktop performance we get on the Dragon Q6A. It's a very, very nice new single board computer. The Qualcomm chip clearly is doing a very good job on this board. And the final thing I want to point out before we move on to do some specific benchmarks is that we do have here a graphical software center pre-installed. We don't always see those on ARM single board computers in the available distros. And so what I'm now going to do is to install some software, including the GNU image manipulation program, so we can use them in some tests. Greetings! We're now all set up to check out comparative performance, and if you can hear a small whine in the background, it's because I've added this small fan on top of the heatsink just to make sure our CPU cores don't throttle during our tests. And as you might have noticed, I've got BTOP in the background here, and we can see we're now idling at about 28 degrees. I'm very happy with that, although I'm going to close BTOP down. I don't want to have it running and potentially contaminating any of our tests. Talking of which, the first test will be this one, my standard Sysbench CPU test. It'll factor prime numbers to a maximum number of events of 10,000. This should be a very quick test, so let's run it, just a few seconds. See how long it takes. There we are, it took about 1.7 seconds. That is a good result, although it's only meaningful via comparison, so let's put it onto this table that shows lots of test results for 3 boards I've tested in the past, specifically a Raspberry Pi 5, a ROC 5 ITX, which has got an RK3588 SoC as I was talking about earlier, and we've also got an Intel M100 system. And it's worth pointing out that both the ROC 5 ITX and the M100 DC ITX systems we're using here to represent RK3588 and M100 are fairly high-end systems based on these chips that I've tested previously on the channel. Anyway, based on the Sysbench result, the Dragon Q6A is already winning, so let's go and perform some more tests. And here on the desktop, we're all set up to run Geekbench, so let's execute that. And this will take a little time, so we'll use the magic of filmmaking to speed on through. And there we are, it's finished. And because Geekbench for ARM is only in preview, we have to look at our results online. We can't register this copy and see them here. But just before we do that, I'm going to quickly go into System and run up BTOP. Just have a look at the temperature, which looks fine. Clearly, I don't know where it got to, but obviously wasn't going to be problematic there, was it? So anyway, let's go and look at our results. And there they are, 1174 single core, 3175 multi-core. And with a Geekbench result, the higher the better. So let's put these across onto our table, where the Dragon Q6A has got the best multi-core score in Geekbench, and it's pretty close to the Intel M100 in terms of single core performance. It's clearly beating the other 2 ARM boards. So let's move on to another test, which is going to be Silverbench, and this is a browser-based CPU ray tracing test, and it's important to note this has to be run in a Chromium-based browser. So here I have installed Chromium to run this test, so let's click on Benchmark. Here it goes, and once again this will take some time, so we'll speed on through the test, and note that as we Geekbench, the higher score here, the better. And there we are, it's finished with a score of P13884. So let's put that across onto our table, where, as we can see, the Dragon Q6A again outperforms the other two ARM boards, but isn't quite as powerful as the Intel N100 system. So let's now move on to some tests using real applications. I've installed here, for example, the GNU image manipulation program. It's not the latest version, but it came up nice and fast, didn't it? So let's just do a file and new, a standard 1920 by 1080 image like that. I'm going to do my standard test, which is filters and render and lava like that. So let's bring up a clock and run the test. I wonder how long this real world test will take. It's already taken longer than I expected. Let's see how long it's going to be. And there we are. It's completed the render in 8.8 seconds. And if we put this across onto the table, we can see that's faster than a Raspberry Pi 5, but slower than an RK3588 and a lot slower than the Intel M100 system. It's always good, I think, to throw in some real-world application tests. Talking of which, I did intend at this point to run a Kdenlive test. Let's just discard my changes here. There we are. And I have installed Kdenlive sitting there under multimedia, but if I try and run it up, it crashes. Yes, it crashed last time as well, and we keep resetting, and it keeps having a go, and it keeps not running. Now that might be something I can do, I don't know, but anyway, I've been messing around quite a bit. I can't get Kdenlive to run on this system, and so we cannot run the Kdenlive test. We will record it as will not run on the table, and I guess we may have to chalk this down to the fact we are running a developmental version of the operating system. Next, let's move on to some drive speed tests, and for this, in addition to our NVMe SSD, I've got a 128GB UFS module plugged in onto the board, and I've also inserted a microSD card. And so if I do an LSBLK to look at the block devices on the system, we can see all of these here are NVMe SSD, microSD card, and our UFS module, which appears as SDA. So let's start out with a test of our NVMe SSD. There's the HD parameters test. Let's just put this bit further up on the screen like that and run the test. Here we go. See what result we get. Very exciting. I do like running drive speed tests. And there we are, 1094 megabytes a second. And let's now run the test for our UFS module. So we'll change this to SDA like that. And this result, I think you'll be surprised by. I was surprised first time I ran it. Let's look at this. We get 1155, faster than the NVMe SSD, and a clear indication of why it's good to use UFS modules on SBCs if we can. Finally though, we'll also test the microSD card, MMCBLK1. There we are. That won't be that fast. If it is, I will eat my hat. I won't be eating hats, I'm sure, because we'll get a speed of 77 megabytes a second. So let's go across to our table and drop in the result for the NVMe SSD. We don't have slots for the other storage media, but we can see the NVMe SSD is working faster than the drive on a Raspberry Pi 5, but slower than the drives on the other systems. So the final details to fill in here are power use, and during the tests I've been monitoring this using a power meter where I've recorded 4.7 watts at idle and a maximum power draw of 11.8 watts at load, although it does bound around as we can see. And it's worth noting this is with an NVMe SSD and a UFS module and the fan connected to the board. Although still, it's not a bad power use, higher than a Raspberry Pi 5, but lower than the RK3588 based system and much lower than an M100 PC. And so there we are. In aggregate, I think these are very impressive results for the Dragon Q6A. It is a very nice Qualcomm based ARM computer. Right, just before we close, I thought we'd test out another operating system on the board, and so here we are running Fedora. And if I launch the Firefox web browser, I can show you how I got hold of the image. It's a development image for Fedora, it's not finished yet, but here we are, it's for the Dragon Q6A, it's Fedora 42, and it works very well indeed, except for the fact we don't have working audio. And indeed, we go here to settings, like that. We will see under sound we just have a dummy output. We don't have audio support yet, but I'm sure they'll fix this in the future. And whilst we're here, let's go down to System and to About and click on System Details down here, where we can see we are definitely running on the Dragon Q6A. It'd be strange if we weren't. And we're running Fedora Linux 42, as we just saw, with a GNOME 48 desktop, the Wayland windowing system, and Linux kernel 617, rather a new Linux kernel. This is very exciting indeed. I should point out we're actually running Fedora here from a micro SD card in a USB reader. And I'm doing this purely to test booting from USB, which clearly works, no problems at all. If we just go and have a look at what software is pre-installed, it is basically what we have here. I did install the Firefox browser and indeed the Chromium browser. I did that using the Software Center, which works absolutely fine. But other than that, what you see is what's pre-installed in the development image. We do have LibreOffice Writer and the rest of LibreOffice. As you can see, this is a very responsive, very usable system, and that's really the main thing I want to tell you about running Fedora on this board. Although, as a final little demonstration, let's launch the Chromium web browser, and this has got a bookmark to my Christopher Barnett YouTube channel and my test video, so let's just bring up my test video. We'll make sure we're in 1080p like that, never trust the auto, and we'll go to Stats for Nerds, and as you can see, it just works. We don't have drop frames. Admittedly, no audio, we can't hear what the ducks are quacking to each other, but I do remain very impressed indeed with the desktop computing experience on the Dragon Q6A. The Dragon Q6A is one of the best new single-board computers that I've reviewed for some time. Software may still be in development, but as we've seen, is already good. And whilst the board is designed for IoT and Edge AI applications, it's also an excellent general purpose ARM computer that sells for a reasonable price. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.